A mysterious wave-like structure in our galaxy is found to be slowly slithering. Now, in this animation showing the motion of the Radcliffe Wave, the yellow dot represents our Sun. Now, gazing out upon the apparently unchanging sea of stars around us, it's tempting to think of the Milky Way galaxy as static and everything within it as fixed and immutable. While the timescales on which our galaxy moves often defies human experience, it does indeed. Now, not all of these dynamic processes are easy to see. Just a few years ago, scientists discovered a huge wave-shaped structure extending some 9,000 light years in length, snaking along a spiral arm of the Milky Way galaxy, just 500 light years from the solar system at its closest point. Named the Radcliffe Wave, this squiggle of star-forming gas is in itself a remarkable discovery, and there's a lot we still don't know about it, but a team of scientists led by astrophysicist Ralf Konietzka of Harvard University has just learned one thing. Like many objects in the Milky Way, the Radcliffe Wave is in motion. And not just an orbital motion around the galactic center. The Radcliffe Wave is oscillating as a periodic traveling wave. By using the motion of baby stars born in gaseous clouds along the Radcliffe Wave, Konietzka explains, we can trace the motion of their natal gas to show that the Radcliffe Wave is actually waving. Our understanding of the three-dimensional properties of the Milky Way has improved dramatically in recent years, largely thanks to a project known as Gaia. Gaia is a spacecraft that shares Earth's orbit around the Sun and has been carefully mapping the Milky Way for several years. It uses parallax to measure with high precision the positions of stars in 3 dimensions, but that's not all. It also measures properties such as their proper motion and velocity. This means that we now have the most accurate map of the Milky Way to date, including the position of stars, the direction of travel, and how fast they're moving. Scientists using this data to discover the Radcliffe Wave back in 2018, publishing their findings in 2020 after putting together a 3D map of the structure. There wasn't enough information at the time to understand the structure in greater detail, but a subsequent release of additional Gaia data has provided vital information. With this, the researchers were able to assign positions and motions to clusters of baby stars embedded in the star-forming material that makes up the Radcliffe Wave. Extrapolating from this information, the researchers found that the structure is indeed undulating like a giant cosmic serpent winding through the Milky Way. The team's calculations reveal that this motion can be influenced by the gravity produced by normal matter in the galaxy. We don't need to start mapping out dark matter to explain it. The team's measurements even suggest that the supernova that virtually cleared the bubble of space in which the Milky Way resides was born in a cluster of stars within the Radcliffe Wave. But naturally, there are far more questions to be answered. Why did the wave form? And why is it moving like it does? And how many of them are out there? Is the Milky Way interwoven with sinusoidal arrangements of undulating gas that are yet to be discovered? The question is, what causes a displacement giving rise to the waving we see? This is astronomer Alyssa Goodman of Harvard University. And does it happen all over the galaxy, in all galaxies? Does it happen occasionally? Does it happen all the time? Theories, the researchers say, range from supernova explosions to gravitational interactions with satellite galaxies and encounters with other large galaxies. We know that the Milky Way has joined with multiple other galaxies in the past, and that it appears to be currently undergoing another collision. Research last year found that dark matter can have a pretty dramatic effect on the overall structure of the galaxy. There are many factors that could be at play. Upcoming deep and wide surveys of stars, dust, and galaxy and gas will likely uncover more wave-like structures, the researchers write, and measurements of their motions should provide insight into the star formation histories and gravitational potentials of galaxies. The team's findings have been published in Nature magazine. This is on Science Alert by Michelle Starr. Now, they do mention here that we are undergoing another collision currently, and that's because we're going to be colliding with the Andromeda Galaxy. And the pink cloud of it can be seen from the southern hemisphere. A couple of months back, I did post a video on that. Maybe I should look into that again and repost some more information on that. This is on Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.